All right, today we're literally decoding the field. We're going to dive into this really cool intersection of nature and technology to see how artificial intelligence can look at something as organic as a patch of grass and make sense of it. And this has huge implications for everything from farming to environmental science.
I mean, it sounds a little like science fiction, doesn't it? But that's the core question we're tackling today. Can a computer actually look at a photo of a pasture and tell us how much grass is there, right down to the gram?
Well, the answer, believe it or not, is a big yes. And the how is all packed into this Python script. So in this explainer, we're going to walk through that code step by step to see exactly how it works.
Okay, so here's our game plan. We'll start with the challenge itself, the grass reading AI. Then we'll meet the tools for the job. We'll walk through the three-step pipeline, watch the different AI models face off in a showdown, and then, of course, we'll crown the winner.
So you might be asking, why do we even need an AI to look at grass? Well, it's actually a huge deal. For farmers and scientists, knowing the biomass, that's just the total weight of all the organic stuff, is super important for managing livestock or monitoring ecosystems. The problem is going out and measuring it by hand. It's slow, it's expensive, and you just can't do it over large areas efficiently.
And here's what's really amazing: the level of detail we're looking for. The AI isn't just spitting out one number. Nope. It has to predict 5 different values from every single photo. It's got to separate the green grass from the dead stuff and even pick out the clover. This list here, it's pulled right from the targets defined in the code.
All right, so to tackle a problem like this, you basically need 2 things, right? You need good ingredients and a really good chef. And in the world of AI, that translates to having top-notch data and a powerful model to make sense of it all. So on one side, we have our data. These are our ingredients, a whole bunch of photos of pastures. And for each one, someone has gone and physically measured the real biomass values. And on the other side, we have the brain, our chef. This is a super sophisticated pre-trained AI that already knows a ton about how to understand images.
And that brain has a name. It's called DINOv2, a model from Meta AI. Now, the best way to think about this thing is like a universal translator, but for images. It can't weigh the grass itself, but what it can do is look at any picture and turn it into this incredibly detailed numerical description, like a digital fingerprint that other, simpler programs can actually work with. Okay, so if DINOv2 is our master translator, the expert, we also need a few specialist apprentices. These are much simpler machine learning models. Their one and only job is to take those detailed fingerprints from DINOv2 and learn how to connect them to our 5 target grass weights. That's it. And the code actually sets up a little competition. We've got 3 main contenders here: LightGBM, XGBoost, and CatBoost. Now, these aren't just random names. These are all absolute powerhouses in the machine learning world. They're known for being super fast, really accurate, and just fantastic at finding patterns in numerical data, exactly like the fingerprints DINOv2 gives us. So we're going to train all 3 and see who's best for the job.
All right, we've met the players. We have our tools. Now let's look at the actual process, the assembly line that takes us from a simple photo all the way to a useful insight.
The whole pipeline is actually pretty straightforward. It boils down to 3 main steps. First, we extract the important information, the features, from the images. Then, we train our apprentice models with that info. And finally, we put them through some tough tests to see how well they've actually learned their job.
So, step 1 is where DINOv2 really gets to shine. The code calls this function extract dense features. This is the part where every single pasture photo gets fed into DINOv2, and what comes out the other side is that rich, numerical fingerprint we keep talking about. It's that magic moment where pixels become data that a computer can actually understand.
Okay, once we have that data, we use it to train our 3 apprentice models. But here's the thing. We don't just train them once and cross our fingers. We use this really robust technique called cross-validation. You can think of 5-fold cross-validation as giving each model 5 different dress rehearsals. We slice the data into 5 pieces, and then we train and test the model 5 separate times, each time holding out a different piece for the test. This just makes sure the model is genuinely learning, not just memorizing the answers.
All right, now this is where it gets fun. After all that training, after all those dress rehearsals, the code spits out the results. It's time for the showdown. Let's compare our 3 contenders and see who really nailed it.
So as the script is running, you'll see it print out the performance score for each model across each of those 5 tests, or folds. The metric we're looking at is called the weighted R2 score. Now, you don't need to get lost in the math. All you need to know is that it tells us how well our model's predictions explain what's actually happening with the grass weight. A score of 1 would be a perfect prediction, so the closer we get to 1, the better.
So the code crunches the numbers and averages out those 5 scores for each model, and the results are pretty interesting. You can see XGBoost does a decent job, but it's a little behind the others. LightGBM and CatBoost, though, are neck and neck, but you can see CatBoost just inches ahead with a slightly better average score. And check out that standard deviation, it's lower, which means CatBoost was also the most consistent performer.
Okay, so after that nail-biter of a race, it's time to officially crown our champion and take a closer look at what makes it the best model for this job.
So, the big question is, which one of our apprentices came out on top?
This bar chart, which the script generates for us, makes it totally clear. You can see that highest bar belongs to CatBoost, showing it had the best average performance. And see those little black lines on top? Those are the error bars. The smaller they are, the more consistent the model was. So not only did CatBoost win, it was a reliable winner.
And that winning score for CatBoost? An average of 0.6289. That makes it our champion for this task.
But the story doesn't just end with finding a winner. The code is smart about this. It identifies CatBoost as the best performer, and then immediately puts it to work, using this fully trained and tested model to make the final predictions on a whole new set of images it's never seen before. You know, if there's one big idea to take away from all of this, it's this. We aren't building some monster AI from scratch. The real power here is in the approach. We're using a massive general-purpose AI like DINOv2 to do the heavy lifting, to understand the rich information in the picture. Then we're training a small, super efficient model to solve one very specific problem. It's just a really smart and effective way to do things.
So we started with what seems like a pretty specific problem, right? Weighing grass. But the technique we just walked through is incredibly versatile. I mean, if an AI can learn to see biomass in a field, what other invisible patterns could it learn to spot? Think about things like the early signs of crop disease or subtle changes in soil health. What else can it see that we can't? The possibilities are really as vast as the fields themselves.